Hey guys, hope everybody's doing well. Like I said, I'm just gonna run through this practice test. You guys can check your answers, as we go. Um, what I'm gonna do is in the description down below, I'm gonna give the times that I go over each question, so you guys can kind of jump ahead, look at what you want to look at and go from there. And like I said in class, you guys can always come see me, if you want to go over anything in particular. All right. All right. Here we go. All right. So the first couple are just inverse trig questions. So you want to make sure that you're kind of remembering, which function you're talking about and where that function is defined, and so on and so forth. Alright, so for the first one I see inverse tan of 2 pi over 3. So what I want to do first is I want to evaluate this inside part. Okay, so tangent of 2 pi over 3. Alright, so I look on my unit circle. I have 2 pi over 3. Alright, I want to do the y term over the x term. Alright, so that's 2 pi over 3 is negative 1/2, and then root 3 over 2. So I'm going to do root 3 over 2 divided by negative 1/2, and that's going to be negative root 3. Okay, so what's going to happen is that tangent of 2 pi over 3 turns into negative root 3. So now you got tangent, inverse tangent of negative root 3. Alright, now with inverse tan, right, if you guys are looking at your unit circle, inverse tan only covers the right side of the circle. Okay, so I want to see where does, which of those angles is going to give me negative root 3. Okay, now if I look back at 2 pi over 3, right, I see that my y term was root 3 over 2, my x term is negative 1/2. Alright, I still want that same formula, alright, but I might be able to change maybe the negative to be the y term be negative and the x term be positive. Okay, so if I look down here, that same combination is right here at negative pi over 3. Okay, if you look right there, you still have that same combination of root 3 over 2 divided by 1/2, but now just the y term is the one that's negative. So when you do that, you're still going to get negative root 3. Okay, so that there is my answer. Be negative pi over 3. Alright, so for letter B, you're doing inverse sine of negative pi over 4. Again, you're going to evaluate the inside part first. So sine of negative pi over 4. Alright, so if you guys look on your unit circle, that's the same thing. 7 pi over 4 is the same thing as negative pi over 4. Okay, so I'm looking at the y term there, which is negative root 2 over 2. Alright, and then I have the inverse sine of negative root 2 over 2. And again, where's the y term equal to negative root 2 over 2? Remember, inverse sine is also just the right side of the unit circle. Okay, so it's actually right where I started, which is negative pi over 4. Okay, letter C, again, same thing, you're evaluating the inside part first. Alright, so inverse sine of negative root 3 over 2. So where is the y value equal to negative root 3 over 2? And that would be negative pi over 3. Okay, so then now you're doing tangent of negative pi over 3. Alright, which would be the y term over the x term. Okay, so that would be negative root 3 over 2 divided by 1/2, and that's going to be negative root 3. Okay, now moving on to the last one, I got tangent of inverse sine of negative 4/5. Now this number here, negative 4/5, is not on the unit circle. Okay, so if you see a ratio that's not on the unit circle, it would be really helpful to kind of draw that out. Alright, now because it's negative, right, inverse sine is either the first or the fourth quadrant. Because it's negative, it's going to go down in the fourth quadrant. Alright, and you label your sides based off of this angle right here. So that's negative 4, and that would be 5. Okay, so if you do Pythagorean theorem, that'll give you 3 for the missing side. Okay, so remember, this inside part here is going to turn into that angle. Okay, so then what you have is tangent of that same angle. So if you look at the triangle and you do the tangent ratio, you get negative 4/3. Right, and that's the inverse trig part. Okay, now the next part, you're just doing identities. So the big thing with these is you really just want to not mess with, but just really work with one side. You know, you're trying to show that the one side is the same thing as the other. Okay, so for the first one, what I want to do is I'm going to use the right side. I'm going to change tangent. Okay, so what that's going to give me is 1 over 1 minus sine over cosine. Okay, so now I see I have a fraction, a smaller fraction built inside of a bigger fraction. Okay, so what I'm going to do is I'm going to multiply the top and the bottom by that denominator. Right, and by me doing that, that's going to allow me to get rid of that fraction. Okay, so cosine times 1 is cosine, and then I have cosine times 1 again is cosine, minus sine over cosine times cosine. The cosines will cancel out, and you're left with sine of x. Okay, and if you guys can see, that's what you have on the other side there. All right, so your first proof is done. Okay. Now, looking at the second one. Okay, let's see here. Okay, so what I would probably do is work with the left side. Alright, so I have 1 minus sine over secant. Now, 1 minus sine, to really do anything with that, you know, anytime that you guys see a factor where it's 1 minus something or 1 plus something, what you can do is then multiply that by its opposite. Okay, and what the opposite of 1 minus sine is would be 1 plus sine. Okay, so what you're going to do is you're going to multiply the top and the bottom there by 1 plus sine, right? Because that's the opposite of that factor. Alright, so when you do that, it's a difference of 2 squares. So you have 1 minus sine squared. Okay, and then on the bottom you have secant times 1 plus sine. Okay, now if you look at the other side, right, you need 1 plus sine in the denominator, and you have that now. Okay, so now what you have to try and do is, okay, I have to come up with cosine to the third power. Okay, so if you simplify 1 minus sine squared, that's cosine squared. Okay, and then secant is 1 over cosine. Okay, so just remember, sine squared plus cosine squared is equal to 1, right? That's an identity. So you guys are allowed to move terms around so that you can, you know, kind of use what you want. Right? So what I did is I moved sine squared over, right? So cosine squared is the same thing as 1 minus sine squared. Okay, so if I keep simplifying, right, I have cosine squared divided by 1 plus sine over cosine. Okay? And I run into the same issue that I had in the last problem where I want to get rid of that denominator. So if you do that by multiplying on the top and the bottom there, what you're left with would be cosine to the third divided by 1 plus sine over cosine times cosine. The cosines cancel out. Alright, and then you're left with 1 plus sine on the bottom, which is what you wanted. So that's good for the second one. Okay. The third one, obviously you want to use the left side, okay? And when in doubt, try and change everything in terms of sine and cosine, okay? So tangent is going to change to be sine over cosine, and then cotangent is cosine over sine. Okay, and then on the bottom I have 1 over cosine times 1 over sine. Okay, so what I want to do next is I want to try and put both of these terms together. Okay, I want to make it one single term. Okay, so what I have to do is I have to find a common denominator. So I'm going to multiply the first term by sine over sine, and then I'm going to multiply the second term by cosine over cosine, and that'll help me give me the sine times cosine common denominator. Okay, so what that'll do, sine times sine is sine squared. Okay, and then cosine times cosine is cosine squared over sine times cosine. Okay, and then that is all over 1 over sine times cosine. Alright, and you guys should be kind of recognizing where the answer is coming from now. So this 1 sine squared plus cosine squared is going to turn into 1. Okay, so now you have 1 over sine times cosine divided by 1 over sine times cosine. Okay, anything divided by itself is just 1. So you're done with the third one. Alright, letter D. Again, I want to use the left side because there's more stuff that I can work with. Okay, so what I'm going to do is I'm going to get rid of this here. Okay, and so what I want to do, I want to try and get a common term, right? I have one term on the right, so I'm going to try and do that on the left side as well. So I need to come up with a common denominator again. Okay, so the first term I'm going to multiply by sine over sine. Okay, and then the second term I'm going to multiply by 1 plus cosine divided by 1 plus cosine. Okay. Alright, when I do sine times sine, that'd be sine squared. Okay, and then I have 1 plus cosine times 1 plus cosine is 1 plus cosine squared, right? And then I have sine times 1 plus cosine. Alright. Okay, now from there I can't really do anything. I can't really factor anything out. I can't use any identities right now. So really the only option that I have is that this little 2 here, I can multiply those two factors out. Okay, so I'm going to do 1 plus cosine times 1 plus cosine. And what that's going to do, that's going to turn into 1 times 1 is 1. 1 times cosine is cosine. Cosine times 1 is cosine. So cosine plus cosine is 2 cosine. And then cosine times cosine is cosine squared. And that's divided by sine times 1 plus cosine. Okay. Okay. Now you guys should be able to recognize that you have sine squared plus cosine squared, right? And you can put that together and make it 1. Okay. So now you have, put those two together and make it 1. Okay. So now you have 1 plus 1, which is 2, plus 2 cosine, okay, divided by sine times 1 plus cosine. Okay, now on the top I see that I have a common term. I can take out a 2. That's leaving me 1 plus cosine over sine times 1 plus cosine. Alright, and you guys should be able to see, okay, I have a common factor now that I can get rid of. Okay, and that's going to give me now 2 over sine of x. Right, and that's going to turn into 2 cosecant of x, which is what you have there on the other side. Alright, letter E. I have 1 minus sine squared over 1 minus cosine. Okay, let's see. Alright, so what I want to do is I'm going to try and change this. Okay, I know sine squared is equal to 1 minus cosine squared. Okay, so what that's going to give me is 1 minus cosine squared over 1 minus cosine. Alright, what I want to try, I'm going to try and eliminate this fraction. Okay, so 1 minus cosine squared is the difference of 2 squares, right? So if you factor that, right, what that'll give you is 1 plus cosine times 1 minus cosine over 1 minus cosine. Okay. Now you should recognize, okay, now I can eliminate 1 minus cosine, 1 minus cosine. Okay, so that's going to leave you with 1 minus 1 plus cosine. So if you distribute your negative, you get 1 minus 1 minus cosine of x, right? The 1's are going to cancel out, and you're left with negative cosine of x, which is what you started with there on the right side. Okay. Excuse me. Okay, and then the last one. I think I'm gonna use the left side. Okay, and what I'm gonna do is I see over here I have just cosine squared, but over here on the left side I have both sine and cosine. Okay, so what I'm going to try and do is I'm going to change sine squared so that's in terms of cosine, just so that I get the same function across the board. Okay, so I'm going to get 5 cosine squared plus 3, and then I'm going to change sine squared to be 1 minus cosine squared. Okay, so that's going to give me 5 cosine squared plus 3 minus 3 cosine squared. And if you combine your like terms, you get 2 cosine squared plus 3, which is what you have there on the other side. So those there are my common terms, right? 5 minus 3 gives you 2. All right, and those are your proofs. Look over the worksheet that I gave you guys a couple weeks ago to look that over as well. And that should help you come up with those. Just remember, you're always doing one side. You don't have to do both. Just take your time. Okay, number 3. It says find the exact value of cosine of 5 pi over 12. Use a sum or difference formula. Okay, so I need to think of 2 angles that add together that gives me 5 pi over 12. Okay, so 5 pi over 12 is the same thing as 3 pi over 12 plus 2 pi over 12. Okay, and 3 pi over 12 I know is pi over 4, and 2 pi over 12 is pi over 6. Okay, both of those angles are on the unit circle, and I can come up with those values pretty easily. All right, so I'm going to be using the sum formula for cosine. Okay, so that's cosine of pi over 4 plus pi over 6. Okay. Alright, so the sum formula for cosine is cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. Alright, so if you guys refer to your unit circle for this, you should be able to come up with the values. So cosine of pi over 4 is root 2 over 2, cosine of pi over 6 is root 3 over 2, minus sine of pi over 4 is root 2 over 2, sine of pi over 6 is 1/2. So from there, all you're doing is just multiplying through. So you get root 6 over 4 minus root 2 over 4. So your final answer is root 6 minus root 2 over 4. All right. So the biggest thing for this is, again, just coming up with the two angles. These two angles here must be on the unit circle, because that's how you're going to get your ratios to come up with the final answer. Alright. And then for part B, it says cosecant is 3/2 and cosine is negative. Find sine of 2x and cosine of 2x. Okay. So for both of these, I need the sine ratio and the cosine ratio. Okay. So sine of x is the opposite of cosecant, so that's going to be 2/3. Okay. And then it says cosine is negative. So if sine is positive and cosine is negative, that means it's got to be in the second quadrant. Okay. So this will be 2, this will be 3. And then if you find the missing side, you'll find that that's negative root 5. Okay. So the cosine of that angle would be negative root 5 over 3, right? Adjacent over hypotenuse. Alright, so now that I have that information, I can figure out what sine of 2x is. Okay, sine of 2x would be 2 times sine times cosine. Okay, and then all you're doing is just plugging in your ratios. So you have sine of x, which is 2/3, and you have cosine of x, which is negative root 5 over 3. Alright, so 2 times 2 is 4, times negative root 5 is negative 4 root 5. And then 1 times 3 is 9. So sine of 2x is negative 4 root 5 over 9. Okay, and then the last one you have is cosine of 2x. Okay, now cosine of 2x is cosine squared minus sine squared. Okay, and then all you're doing is just plugging in your ratios. So cosine is negative root 5 over 3 squared minus sine squared is 2/3 squared. Okay, so when I square negative root 5 over 3 out, that's going to give me 5 over 9, and then minus 4 over 9. So your final answer would be 1/9. All right, again, you guys are gonna get a bunch of the identities and stuff like that on the test. So you should be pretty set for that. Okay, number 4. Use the given information to find sine of a minus b. So it gives me a secant ratio of a and a secant ratio for b. Okay. Alright, so when I'm doing this out, right, sine of a minus b, alright, that's the difference formula for sine. So it's sine of angle A cosine of b minus sine of b cosine of a. Okay, so these are all ratios that I need to find. Okay, and where I'm going to get them from is this information here. Okay, so it tells me that the secant ratio of angle A is 2, and it's between negative pi over 2 and 0. Alright, so what I'm going to do is I'm going to draw that out. Alright, so it's between negative pi over 2 and 0, which is puts it down here. Okay, and the secant ratio is 2, right, or 2 over 1. Right, remember that would be hypotenuse over adjacent, so 2 over 1. And then that would make the missing side negative root 3. So just do Pythagorean theorem to come up with that. Alright, so if you do sine of angle A, opposite over adjacent, opposite over hypotenuse, excuse me, so negative root 3 over 2, and then cosine of A would be 1/2, or opposite of secant. Okay, so now you have both of those values to help you, eventually simplify. All right, and then the other one, you have secant of B is between 3 pi over 2 and 2 pi. Okay, so that also is in the fourth quadrant. Okay, so it tells me that the secant ratio is 3, so that would make this 3 over 1, and then your missing side would be negative root 8, or I'm going to do negative 2 root 2. Okay, so sine of B would be opposite over adjacent, so negative 2 root 2 over 3, and then cosine of B is 1/3, or the opposite of secant. Alright? Okay, so now that you have all that information, you can now figure out the answer to the question. Okay, so you have, so coming down here, sine of A, cosine of B, minus sine of B, cosine of A. All right, I'm just rewriting the question. So sine of A, I figured out was negative root 3 over 2. Cosine of B, I figured out was 1/3. Minus sine of B, I figured out was negative 2 root 2 over 3. And then cosine of A is 1/2. Alright, so you're just multiplying through now. So it's negative root 3 over 6 plus, now it's becoming a plus because you have two negatives, here and here. Alright, so just pay attention to that when you're working it out on the test. So you got 2 root 2 over 6. So you have a common denominator, so you can just add them together. So it would be 2 root 2 minus root 3 over positive 6. Right? You can either have that or negative root 3 plus 2 root 2 over 6. Either one of them is appropriate. Alright, so again, use the information that they give you to figure out the information that you don't have. And it's all just drawing it out. Okay? Just drawing out to come up with the ratios. Okay, the last one, or last question I should say, is just doing the trig equations. Now all of these are going to be from 0 to 2 pi. Okay, so that kind of limits my answers. And again, you're going to need your unit circle out for these. So the first one, sine of 2x plus 1 is equal to 0. So this 2x, okay, tells me that I'm going to get multiple angles. All right, and we did a couple problems like this. You know, this is kind of like the multi-step one. So the first thing you want to do is figure out where does sine equal negative 1. Okay, so you subtract the 1 over, where does sine equal negative 1? Alright, and you figure that out to be x equals 3 pi over 2 plus 2 pi n. Okay, write that general formula for where does sine, if it was just sine of x equaling negative 1. Okay, so then what you're going to do is you're going to take that solution and you're going to divide it by 2. not 3, 2, because that is the number that's in front of the x term there. Okay? So what that's going to do is it's now going to turn your general solution to be 3 pi over 2 divided by 2 is 3 pi over 4, plus 2 pi over 2 is pi. Alright, so that solution at 3 pi over 4 is going to repeat every pi radians. Okay? So what you have now is you're just going to list your solutions. Okay? So 3 pi over 4 would be your first solution, right? And you're going to add 1 pi to that. And 1 pi in this case is 4 pi over 4. So 3 pi over 4 plus 4 pi over 4 is 7 pi over 4. Okay? So those are your two answers, right? You don't want to go over 2 pi. So just make sure you're paying attention to that as well. All right. The next one, I see that I have sine squared on the left and then some terms on the right. So what I'm going to do is put everything on the left side. So 2 sine squared minus 3 sine of x plus 1 is equal to 0. And what I can do now is just factor. Right, so it's a trinomial, so you need 2 binomials. So 2 sine squared, you have 2 sine times sine. Okay, and then I see that the middle term is negative and my last term is positive. So that means that my two factors for positive 1, they need to both be negative so that I get the negative middle term. So that's going to be minus 1, minus 1. Okay, so when you do 2 sine times negative 1, that's negative 2 sine times another negative sine is negative 3 sine. So always check your multiplication when you're doing these. Alright, so your two factors now are 2 sine minus 1 equals 0, and then sine minus 1 equals 0. Okay, so solve for the trig equation. So you have sine of x equals 1/2, and you have sine of x is equal to 1. Okay, so where does sine equal 1/2? That would be pi over 6 and 5 pi over 6. Alright, and then the other one you have, where does sine equal 1? And that would be pi over 2. Alright, so again, just make sure you have your unit circle out for these so that you're getting the correct answers. Okay, for the next one, I see that I have a cosine term and a sine squared term. Right? So because I don't have the same function across the board, what I want to try and do is change that. Okay, so I can't really do anything with the cosine, but I can change sine squared in terms of cosine. So make that 1 minus cosine squared. Right? Use your identity in order to do that. All right, so by doing that, it's going to give you 4 minus 4 cosine squared is equal to 1 plus 4 cosine. Okay, so what you want to do from there is just put everything on one side. So I'm going to put the left side over there on the right side. So it's going to be 4 cosine squared plus 4 cosine. And then I'm going to subtract the 4 over, and that's going to give me minus 3. And again, this is another factoring problem. Okay, let's see. So alright, I'm going to split up 4 cosine squared, make it 2 cosine times 2 cosine. Alright, and then I want to break up negative 3, make it 3 and 1. Okay, and I'm going to make this plus 3 minus 1. Okay, so when you multiply that out, it'll give you that plus 4 cosine in the middle there. So you got 2 cosine minus 1 equals 0, and then 2 cosine plus 3 is equal to 0. Okay, so that gives me cosine is equal to 1/2. Okay, and that would make theta would be equal to pi over 3 and 5 pi over 3. Okay, and then the other one you have cosine would be equal to negative 3/2. And if you guys look on the unit circle, you're not going to find negative 3/2 anywhere. Okay, so cosine only goes from -1 to 1. Okay, so that one would be a does not exist. Okay, so your only two solutions would be pi over 3 and 5 pi over 3. Okay, letter D, sine squared minus cosine squared equals 1 plus cosine. Again, I'm going to, I see that I have a cosine term, and then a sine term. So it's probably in my best interest to change the sine squared to be 1 minus cosine squared. Minus cosine squared equals 1 plus cosine. Okay, so what that's going to do is it's going to give me 1 minus 2 cosine squared is equal to 1 plus cosine. Okay, I'm going to put everything on one side, so that's going to give me 2 cosine squared plus cosine of x. If I subtract the 1 over from the left to the right, those will cancel out. Alright, so you have two terms here. They both have a cosine in common, so you're going to factor that out. So you're left with 2 cosine plus 1. Alright, so you have cosine is equal to 0 and 2 cosine plus 1 is equal to 0. Alright, so where does cosine equal 0? That would be pi over 2 and then 3 pi over 2. And then where does cosine equal -1/2 for the other solution? So you have x equals 2 pi over 3 and 4 pi over 3. So those are your four solutions for that one. Okay, the last two. So you have 2 cosine of 2x minus root 2. Alright, so again I'm going to solve for cosine of 2x. So that's going to give me 2 cosine of 2x is equal to root 2. So then you got cosine of 2x equals the root 2 over 2. Now again, because you have cosine of 2x, this is going to be a multiple angle one. Okay, so where does cosine equal root 2 over 2? So that would be pi over 4 plus 2 pi n, and then you have x equals 7 pi over 4 plus 2 pi n. Alright, now what you're going to do now is you're going to take both of those solutions and you're going to divide them by 3. Okay, so pi over 4 divided by 3 is pi over 12 plus 2 pi over 3n. Make sure you divide both terms. And then the other one is going to be x equals 7 pi over 12 plus 2 pi over 3 n. Alright, so now all you have to do from there is just list your solutions. So you're going to start with pi over 12, and then you're going to add 2 pi over 3 to that. Now 2 pi over 3 is the same thing as 8 pi over 12. Okay, so you're going to add 8 pi over 12 now until you get to 2 pi, or 24 pi over 12. Okay, so if you get something that's bigger than 24 pi over 12, it's too big. Okay, so pi over 12 plus 8 pi over 12 is 9 pi over 12, which simplifies to be 3 pi over 4. Alright, 9 pi over 12 plus 8 pi over 12 is 17 pi over 12. And then if I add that again, it's going to be bigger than 24 pi over 12. Okay, so those are my first three. Okay, so those solutions all come from this first answer. Okay, and then the other ones are going to come from this solution. Alright, so you're going to start with 7 pi over 12. Okay, plus 8 pi over 12 is 15 pi over 12. Okay, which simplifies to be 5 pi over 4. And then 5 pi over 4, or 15 pi over 12 plus 8 pi over 12 is 23 pi over 12. Okay, so those three answers come from that second general solution. All right, so you have six. You should have 6 answers for letter E. Okay, and then the last one, 2 cosine squared equals 7 cosine plus 4. Put everything on one side. Okay, and what you want to do now is try and factor. So you got 2 cosine of x, cosine of x. Okay, so you need factors of 4. So what I'm going to do is I'm going to make this minus 4 and then plus 1, which will give me that negative 7 cosine there in the middle. Okay, so you have 2 cosine of x plus 1 equals 0. So where does cosine equal negative 1/2? And you guys know that that's 2 pi over 3 and 4 pi over 3. Okay, and then the other one you have cosine of x minus 4 equals 0. Where does cosine equal 4? And you should see that on your unit circle cosine never equals 4 because it's too big. So that does not exist. So your only two would be 2 pi over 3 and 4 pi over 3. Alright guys, so that's pretty much the practice test. Again, if you have any questions, feel free to come see me and we can be happy to go over some things with you. Alright? Good luck.